Hello, science students. We are back in the kitchen for another fun science experiment. Today's experiment involves specific heat. All you'll need are a few common household materials and a couple of ice cubes. Okay, let's get started.
Okay, we are in the kitchen. We have our materials. We have wood, which is from a pine tree. We have a lid that is a tin lid that goes on a glass jar. In the middle, we have a brick of aluminium. Here we have a foam dice, a wax candle, and we also have a granite countertop. And what we're going to do is we are going to put an ice cube on top of each item, let it sit for 2 minutes, and then we'll see how much the ice cube melts. Now this will tell us a lot about the specific heat of the substance. Substances with high specific heats transfer heat slowly and there'll be less melting. Items with low specific heats will transfer heat quickly and fast, and you'll see more melting. So by checking out how much the ice cube melts, that'll tell us a lot about the specific heat of each substance: the wood, the two metals, the foam, the wax, and the granite. Okay, so I have my timer going on Alexis, and we will get started. So I'm going to put the ice cubes on each item. So I'll try to do them as quick as I can. Here is foam and this and okay, we're going to start the timer, and here we go. We're going to let it run for 2 minutes. Fun little experiment you can try at home. Now there are definitely more sophisticated experiments you can try, and try in a science lab. You can actually get a really accurate measure of specific heat by using an instrument called a calorimeter. We don't have access to that right now because we are quarantined at home, so we're just using common materials. Alright, if I zoom in, I can already see that the aluminum is causing the ice to melt very quickly. So the aluminum, therefore, would have a low specific heat compared to the foam, which the ice cube has not melted much at all. Very cool. Okay, go back out again here. Also, I can see a puddle forming on the granite by the ice cube. So this would lead me to think that the granite also has a low specific heat. This is really cool to see on time-lapse film as well. We might do that next time. Let's check out the wood here. Okay, the wood has a little bit of dripping, but not much. Not much. The tin has some dripping. I should also point out that this is not a solid chunk of tin. It's just a shell. It's a lid. So the thickness of the material also has something to do with it. Moving on here. If I check the time, we're about a minute and a half in. A minute and a half into our experiment here. And if I can just look at the results here, the aluminum is causing significant melting with most of the ice gone already, just a little tiny sliver left. The granite countertop, half the ice cube is gone. There's a pretty nice puddle of water. On the foam, there's just a few drops, but not much at all. On the wax, a few drops, but not much. Still a lot of ice cube left. And on the wood, just a few drops, barely melted. We have about 15 seconds left in the experiment. Okay. Should also point out that the ice cubes that are in the plastic dish have barely melted. So plastic would have a high specific heat, transferring heat very slowly. Okay, well that concludes the 2 minutes. Now if we look here for the results, the aluminum definitely has the lowest specific heat with just a little tiny sliver of ice cube left. It's all melted, except for that. Granite would come in second place because half the ice cube is gone. Here's a regular ice cube for a reference point. Half it's gone. Third place, I would say, would be the tin lid. Okay, then we have the wood, which barely melted any of it, just a little bit. Then we have the foam. And then we have the wax. So I would say foam, wax, and wood have high specific heat, transfer heat very slowly. And then the metal and the granite would have low specific heat. So we can get more specific. You could compare the different metals, you can compare different woods. This is just a very basic first experiment just to get you going and kind of stir your curiosity. Okay, well thank you very much for listening, and we'll be back next time for another fun experiment in the kitchen.